Okay. Man. Oh, I suck at this.
You don't.
Okay, so really quick, just so he knows we went over them, let's just like say what we got for the first two problems.
Right.
So for the first one, it was negative root 2x minus root 2y plus 2z equals 0.
Yep. Because we found the normal vector and the constant d.
And then for number 2, we got for dz du. What just happened? Okay. 4 cosine v ln of u sine v plus 4 cosine v.
Mm-hmm.
And then negative 4u sine v ln of u sine v plus cosine squared v over sine v.
Right.
And then for the answers, we got 2 root 2 ln of root 2 plus 2 root 2. And okay, wait, say what you got for your second one more time. I want to double check that it is the same as mine.
I remember I put the negative on the right side, so I think it's 4 root 2 minus 4 root times ln of root 2.
Okay.
Yeah.
Yeah, that makes sense. Okay. Cool. Let's do the last one.
Or are these constraints?
What was that?
I think these are constraints, right?
Yes.
Where the right side is a constraint. This part had me so like it took me so long to figure this out.
Constraints.
Right. I guess it makes sense, but I was just like, why? I just couldn't make the like connection for some reason. It was weird.
Yeah, I've done it before. I think I would have also had a hard time with it. Buddy, calm down. It's his nap time, so he's not very happy. I'll be right back.
Okay.
Oh, no problem. I'm still in my meeting. Hoping Gabriel's gonna go to sleep, but we will see. If you can keep him happy. Oh. Okay, wait. So for this kind, when it's not easy to solve for it, you do it implicitly, right?
Yeah, that's what I
Okay.
can solve for dy.
Okay. Are you on the first one or the second one?
On the second, or I'm on the first, or no, I'm just on the first one. whoops.
For the first one, you solve for dz, right?
Right. Or do-
Because well, y is the independent variable. Is that what you're doing?
yeah, or I think I'm substituting for dy as z. So what I do is I find, like I expand this in my mind to w dy times dy t. I expand this in my mind to the right side using the chain rule, where like everything else you can expand it to using the chain rule for everything, but that's the only one that we have to find using the right equation with the implicit differentiation.
Don't you need to do it for z though instead of y? Because z is the one that is dependent.
I don't know.
I don't know. I'm not totally sure like the way you're doing it. But like, first of all, do you agree that z is the dependent variable?
I think it's a constant at this point.
Y is the one that's constant. So like the little ones that are listed out to the side, those are the ones that are also independent.
Yeah.
And so those are the ones that become constants. You look like you disagree.
I'm just confused with this in general, so like if I do, I'm probably wrong.
Let's double check. Yeah, okay. So it's always whichever variable is missing, that is the one that is the constraint.
Yeah.
So like on this problem, there's x in the denominator and then y on the outside, but z is missing. So z is the one that is the dependent that you want to make like dz.
Yeah.
So I think you do it the same way that you're doing it, but you do it for z instead of for y.
Okay.
Does that make sense?
Oh. Okay. Yeah, I think you're right. Yeah. Okay. When I learned kind of how it worked on Math Lab, and they like turned the two that were like specified into U and V, so that made me think, um, you know,
Oh.
like different functions, but then they turned those into ones, and now that's weird. This is weirding me out. Hey, it's uber confused. I don't know what they're doing. Okay, so okay. X, Y, Z. Yeah, you're right. That's probably why I'm having so much trouble with this.
Oh, just that one simple
Yeah,
misunderstanding.
that's weird. Why is it like that?
I don't know. Like you'd think that like they would put the one that you want to pay attention to in the notation instead of the one that you want to ignore.
Right. I just figured this one makes a lot more sense. Like the way I thought it, like,
Totally, yeah.
well, I know it's wrong now, but it still makes more sense because now it's like an implicit differentiation problem.
Yeah, I agree.
This is weird. Why is this like this? Is it still still let me work on this homework? What the heck? This is like week 7, part 4, and it's still open.
Oh, really?
I don't.
That's Are you in the grade book?
Um, I don't know.
If you're in like a different, like if you're under the homework tab, it usually won't let you work on it unless it's still open for some reason. But if you're like somewhere else, in like for example in the grade book, then you can still open it and like even put in new answers.
Yeah, that's weird. It looks like it's closed actually.
Okay.
Due 6/3, so almost. I don't know. Doesn't hurt to go over and review the problems at least.
Yeah.
I think. Yeah. Okay. So yeah, I did not understand implicit differentiation at this point. So this one is, what are x, y, and z for a? Sorry. Back on the most missed problems, dw dx with this constraint of y. What are x, y, and z?
Um, well, so
Like,
it's not with a constraint of y. Z is the one with the constraint.
okay, so y is a constant at this point, or is it
Yeah.
a
Y
so
is
it's
the
the only
constant.
one that's specified as a constant?
What was that?
It's the only one that's specified as a constant,
Right.
and then x is a dependent variable.
X is independent and Y is independent, but
But
Z depends on X.
okay,
So that's why you have to do Z separately because X is within
mm-hmm.
Z. And so to find the derivative with respect to X, you have to do
Hmm.
the derivative with respect to Z as well.
Okay, so that's funny. That's the only difference was with what I thought it was is that you choose the other one.
Right.
You use like the same formula, but
Yeah.
okay, okay. Equals y sine z sine x equals 0. How artsy. Okay, so what have you done until, so when you find u of w dx with the constraint, or with y constant, you do you get, like in the very first place, 2x plus 2z times dz dx?
Yep.
Yeah. Okay. And for dz dx, do you get negative cosine x all over y cosine z minus sine z, or plus sine z, or sine x? Sorry. Is
Yeah, except I also have a z on top. Negative cosine x times z.
yeah, or negative z cosine x. Did
Oh,
I?
okay, yeah.
I must have not said that. I actually I thought it was a 2 a minute ago. I was like, wait, that's a z. Okay, so yeah, I got that. And then you just plug it in from that point, right?
Yeah.
Okay. 2x plus 2z d r times negative z cosine x. Okay.
Okay, I got negative 2 pi squared.
One, um, two. Oh, z is pi. Whoops. Whoops. 2 pi squared. Okay. Cosine 0, which is just 1. And that cancels out. And then 1 cosine pi negative plus sine of 0, which just goes away. So, wait a minute. Wait, sine 1. Cosine pi, is cosine pi negative?
It's cosine 0, isn't it?
On the bottom, or where it's y cosine z.
Y cosine. Oh, you know what? I wrote that down wrong. I wrote y cosine x, but yeah, it was cosine z. And
Y
so
cosine
that
z.
would be negative, wouldn't it?
Yeah, so the answer is 2 pi squared, not negative 2 pi squared.
Okay.
Yeah.
I agree with that.
Yeah. I mean, like, I'm still very lost in this subject, but that's all that. So 2 pi squared.
Yeah.
And then the magic. Okay. So yeah, that's it. And then for the with y constant and z is the partial.
Yeah.
Okay.
Sorry, I'll be right back.
You good.
There's the study group. Yeah, we have to meet with them every just one person because everyone else dropped out. Yeah. I think this class has a really low retention rate. Okay. It's convenient that you're here. Thank you. Probably 2 hours. Okay, are you finished?
Just about.
Okay.
Sine plus z sine x dx dz equals 0. So, I got 2z plus 2x times negative sine x minus y cosine x all over z cosine.
Yep, that's what I got.
Okay. And that point equals 2 pi plus 2 times 0 times, it's just 2 pi.
Yeah, that's what I got.
Okay. Because the x just cancels everything out on the right side.
Yep.
Okay.
What did you say, Jenna? Oh, actually, it's not. But he's okay with cold water. Yeah. They say not to microwave it because it heats it unevenly and it can burn him. Okay. So do you have any quiz corrections?
I should check this out. Quiz.
This was a tough quiz.
Yeah. Quiz. Quiz 6 or week 6 quiz or week 7 quiz?
Week 6.
6. Okay. Yeah.
I have a question on number 3.
Okay.
This is the only one that I can't figure out what the right answer is.
Ooh, yeah. I don't even think I did all of it. That one was, I did every single one except for like 3, actually.
Mm-hmm.
So I had the same question probably.
Okay.
The only thing
on
I
part
missed.
4.
Part 4.
Yeah, 3 part 4.
Yeah. So.
Okay.
I mean, I kind of have a better understanding now of it, what it actually means, but
I feel like they didn't teach that until like the next time's reading.
right.
And then it was like, oh, and this is all this. Like, oh, gee, that would have been helpful to know for the quiz.
I have free time after the semester's over. I'm just gonna like review all this stuff.
For real.
You want to try to go over it, see if we can get inspiration from on high or something.
Okay.
So 3 part 4. I gotta actually pull up the actual quiz for this one. So
yeah, that's a good idea. I should do that too.
So part 4, that's letter D, right? Or was it letter something part 4?
It was, well, like on the quiz, it had like a list of all the things, and then you'd fill in like A, B, C, or D, like what it was.
I had to like stare at this one for like the longest time. I think what it was that for each function a through e, you had to kind of fill in the blank. I don't know. At that point, like I don't even know. Fill in the blank next to the function with a letter or that. Of course. Oh my gosh. Dang. This makes no sense.
I know. I really don't like the way they set up this question. It was
Okay. I guess the first one's easy. Like scalar valued function of several variables. That's just like f of x and y, and not the capital F, because that's a vector.
okay, wait. So which f of oh yeah, E. Yeah.
Yeah. So
Okay.
that one, several variables, and it's not in vector notation. It's actually the only one that's not in vectors. So
Yeah.
yeah, that one's E. Transformation of R3 to R3.
Did you just say that the capital F means it's a vector?
Yeah, that's I remember.
Oh.
Like I remember, if you look at number 4, I think that's where I learned that the capital F was a vector. Was number 4.
Okay.
Capital F is a vector field dependent on x, y, and z.
Okay.
And I only think I kind of caught that because I kind of like nerded out with my friends in Calc 2, and realized that slope fields were just an introduction to vector fields, where it's just at each and every point, and now in 3 dimensions, it's an angle or a slope, but it's a vector valued slope.
Okay.
So
Okay, cool.
yeah. And then f of xy is just f is just a scalar. Capital F is a vector function, and little f is a scalar function.
Okay, that makes more sense because it seemed kind of random to me, like when they'd use a capital F or a lowercase f, and I was like, "What is the?"
Right.
Okay,
And then
glad there's
R
a
is
rhyme
always
or a reason to the
mhm.
rhyme, rhyme to the reason. I don't
It's potato to your potato. I don't know, but and then
know.
R is always a position vector, and S is now is the length vector. It's kind of interesting. I don't know. It's
Oh,
it's getting interesting.
oh,
So like they choose very like specific ones, and they're being compartmentalist about it. Compartmentalist? That's a weird word. That's not probably right at all. Um,
that is so helpful, though. Thank you.
yeah,
Okay, cool.
yeah. And V is always the derivative of R with respect to T. Like it's never anything else. It shows direction usually.
Okay, that one makes sense.
Mm-hmm. And if they ever do it, then A is the second derivative with respect to T.
Okay, which that makes sense that those would only be for RFT because it's time. So
Right. And they're for like physics and stuff. So
yeah.
um, transformation from R3 to R3. So
For that one, I put B.
that makes sense. Or that one might be C. No, that's not right.
Because R3 to R3 means like you put 3 in and 3 come out.
Yeah. Yep. That is true. That's B. You're right about that. So that's the only one with 3 inputs anyway. I got to look at the inputs. Okay. Vector value function of a scalar.
So that's 1 in, and then a vector comes out.
So that would be A and C.
Yep, I agree with that.
Okay. Or technically, it's a vector value function of a parameter. That's how I see it.
Yeah.
Or maybe the parameters. That one I'm kind of unsure of. Is a parameter could be T, or it could be like X of T and Y of T. Those are the parameters. I'm not actually sure. I should like Google that later.
Yeah.
Parametric surface. That one always is like parametric equation with 2 inputs. So I think that's D.
D.
Yeah,
Oh.
I remember if it's a parametric curve, like in 3 dimensions, it's always just a line that like wiggles its way through. So it has to be a function of 1, but if it's a surface, it's a parametric equation of 2 with 3 outputs.
2 with 3 outputs.
Like
Okay, I need to make sure I've got that one correct in my notes.
yeah.
Surface. Oh, parametric surface. I was looking at surface, which is okay, but it's a parametric surface, which is the other one. 2
Yeah,
inputs,
so
3 outputs. Is that what you said?
right. Yeah,
Okay, so
like
that
R
one's
of
D.
U of B. So if R of T equals like XYZ outputs, then that would always be a line. But if it's R of U of V, it would like, and it equals XYZ, that would always be a surface.
Okay. Cool. That's the one that I had a question on, so
Yeah. Okay.
thank
So
you.
surface would be D. I think that's the only one I got, if I ever did this right. Okay. So
Sorry, I'm just writing down.
yeah. Okay. So okay, these next two didn't click for me until just now. So a plane curve would be on one slice of a 3-dimensional. So it'd be 2-dimensional. So that would be A. Just cosine t negative sine t. That's just two outputs. It wouldn't deviate into the z. But then space curve is where it's 1 in, 3 out.
Yeah, that's what I put.
Yeah. So plane curve would be A, space curve would be C.
And then the last one is the vector field, which that one is obvious. That's the 3 in, 3 out.
Right. Cool.
Okay. Did you have questions on any other parts of the quiz?
I actually did surprisingly well in this. The only other thing I missed 1C. Like I got 0 on that one. I don't know what happened. I also missed 2A, but I probably did that one wrong too. And a little bit on 6. Maybe. Yeah.
Okay. 1C is it's a bunch of parabolas.
Parabolas?
Yeah.
I did have parabolas. Are they just like, are they going out from the center? Or
They're parabolas that just like all face to the right, and they're just like lined up in a row. Like one starts at -4, one starts at -1, one starts at 0, one starts at 1, and one starts at 4, and they all face to the right.
Okay. What was?
I could show you really quick.
Oh, that's strange because it looks so similar to B, which is hyperbolas, you know?
Yeah.
So
Which one? There's a trick that I found. So this one is B. Can you see my mouse moving? Oh, here we go. This one is B. That's the hyperbolas. And then this one is C. And the reason is because B has like 2 things squared in it. It has like x squared and y squared.
Yeah.
But C just has x and then y squared.
Whoops. I put x squared minus y squared.
Oh, like when you wrote it down?
Yeah, so I get that makes sense.
Okay. Yeah.
Cool. Okay.
For number 2, there is this really cool chart. Did you ever find a chart for these?
Oh no,
Because
that would help very much.
the only reason I had it is because when I took this class before, because I took it last semester, but then I had a baby, and so I didn't finish. but all the way at the end of the course, they had a chart for this, and I was like, where was this like months ago? Let's see, stop screen sharing. It starts right here, and it just like lists like every kind of equation, which one that is.
Okay,
I could send you a picture of it if you want.
that would help very much.
Okay, I'll do that.
Yeah, because they all seem pretty straightforward. It's just remembering the words and every single
Yeah.
one of it. So, okay, so
Okay. And then you said number 6.
yeah, I must have. I look like that looks weird. I don't know what I did.
Where did mine go? Oh, here we go. What was number 6 asking? Where's number 6? I have like 5 and then 7. Oh, there we go. Okay. Um,
What'd you get for the vector function? Or did you get, okay, what did it ask for? Did it ask for us to parameterize it?
yeah.
With
Um,
so
so
this is,
I did cylindrical. So I just did like x equals r cosine theta and y equals r sine theta, and then z equals r.
yeah, that's what I put too. Because if you square root both sides, z would equal square root of x squared plus y squared. That would just be r, and then x equals r cosine theta.
So for the function, I got r cosine theta, r sine theta, r. Is that what you got?
Yeah. I must have, what did you put for the bounds? Were there bounds?
Yeah, I put 2 is less than r is less than 4, and then 0 is less than or equal to theta is less than or equal to 2 pi.
I just missed the theta, so.
Oh, you just didn't list the second one?
Yeah.
Oh.
My bad.
Yeah, that makes sense.
So,
I almost forgot. It was when I was like looking back through my work to make sure everything was right, I think, that I was like, oh yeah, I need a bound on theta.
right. Okay, so that's all I missed on these ones. Well,
Okay, cool.
I'm surprised that number 8, I like totally bullcrapped it, but apparently I got it right. So,
That's awesome.
so did you miss anything on anything?
Number 3 was the main one, so.
Yeah, no, number 3 was my main one too. It's
Yeah.
I'll score on that one, but
Okay. Well, I think that's everything then. I don't have any questions from homework this week so far.
it's just cranking down and doing it for me. So
Yeah, this week is nice. It's basically just plugging in the formula.
right, and I actually think it's so fascinating this week. I remember looking these up before.
It totally makes sense. Like, yeah.
Like okay, so I'm using literally what I like learned in physics in high school. Like I had a really good physics teacher, and like he hated calculus, but ironically, he's taught me basically all I know in calculus.
That's awesome. I wish I had a better background in physics because I've never taken physics, but so much of this I think would make a lot more sense if I had.
Right, and I don't know. That's just what I did, and I kind of like it. It's not for everybody, but like
Yeah.
a lot of people take calculus and do really well in physics. So
Yeah, that's true. Okay, well, I guess that's everything.
yeah, that's all I have.
Okay, cool. All right, well, I guess I'll see you next week.
See ya.